Hello, welcome back to another episode of Math with Haas. You're watching Precalculus, Season 2, Episode 13. We're continuing our investigation of trigonometry, and today we are going to determine what are the graphs of our trig functions. So, our first thing we need to do is recall the unit circle, which is this lovely thing right here. Alright. So in the previous video we had derived the unit circle, and I recommended to you that you have this memorized because it's going to be very important when it comes to doing various operations in calculus and pre-calculus. That if you have, say, sine of 2 pi over 3, you just need to know it is square root 3 over 2. So you just need to have that information right there, like your algebra laws. That way you can do more exciting and fun mathematics. Now, what we're going to do is talk about using the unit circle now to find our graphs. So we don't need a calculator, so go away. And you can see some of my background, but whatevs. Alright, so here we are. Here's our unit circle. So let's zoom out a little bit more. Here we go. So if we think about a table of values, right? So let's think about sine theta. So theta and y values. Well, if I plug in a pi over 6, we know we're going to get out a half. Pi over 4, we know we're going to get root 2 over 2. These are all just values we're taking off the unit circle, right? Y sine is the y coordinate, so we look at the y coordinate and say, well, sine of pi over 6, that's a half. And we'll just keep going. Sine of pi over 2 is 1. And then we start getting smaller and smaller values again, right? We go 3 pi over 4, root 2 over 2, plug in a pi, we get 0. We should note that if we plug in 0, we get 0. And I think you have the general idea. Table of values. Let's start making a graph now. Let's see here. Alright, so if I plug 0 into sine, I'm going to get a 0 right here. So let's put a big old point here. Now, if I go, we'll plot this one. So if we go about pi over 4, we'll just call that pi over 4. Then we're going to go root 2 over 2. Now root 2 over 2 is approximately 0.7. So let's just put a 1 up here, 0.7, somewhere about here. And we'll call this -1. And then when we make it to pi over 2, right here, that brings us up here at 1. So it's looking alright. So this looks like we're going up. And it looks like it's going to curve. You can see I don't have the steadiest curve here, but we're getting a general idea. And we can use Desmos to see what it looks like with much better detail. And then notice at pi we're down to 0. We're down here again, right? 3 pi over 4. We were again at root 2 over 2. Well, we're going back down, something like that. And looks like we need some more values. So let's go over. Now, if I go out to 3 pi over 2, well, if we recall, sine of 3 pi over 2 was -1. So that means we're down here now. And if we recall, sine of 2 pi, that is also 0, because 2 pi is coterminal with 0. And this is our sine graph from 0 to 2 pi. it's not very pleasant looking. It's a very shaky job, but we can see we get some kind of wave going on. And in fact, this wave is going to continue on. So if we think about the unit circle, right, this is equivalent to go around the unit circle one time from 0 to 2 pi, which means if I wanted to continue this out, say, let's call this 4 pi, that means I'm going to just be going up and down around my circle. Looks like I missed a 4 pi a little bit, but this is just a rough sketch. By no means professional art here. Alright, so that of course is going to continue on like that. Maybe we should just use Desmos at this point. That looks terrible. Delete. Alright, let's get Desmos. Hello, Desmos, our best friend. See, beautiful free map. Amazing. Alright. Y equals sine x. So there we go. So we can see from here to here is our 2 pi. And we can see if we zoom out, since we're going around the circle over and over for infinity, and we just get this nice wave going on. And this brings us to two significant facts. So when we think about this graph right here from 0 to 2 pi, you could imagine this chunk of it being copied and pasted over and over and over. And so this portion right here is called a period. So this thing I'm highlighting, maybe I should use highlighter to graph. That looks much better. This is called the period. So the initial way we're going to think about the period is just think the range, just how long is the interval of our input variables before our graph starts repeating. And we can see since we start at 0, we go out to 2 pi, that means our period here is 2 pi. We're going to come back to this notion of period, but for now we're just going to make a general note here. Alright, so I would summarize. Sine theta, we have to talk about domain and range. Well, we got the period at least. So period is going to be 2 pi. Now, when we think about domain, right? Domain, if we recall, is what are the legitimate or possible x values you can plug in order to get out a output. And when we look at the graph, well, there's no possible angle you can plug in sine and get something weird going on. Tangent, cotangent, secant, cosecant, we'll find out there's something goofy going on. But with sine, nothing weird is going on. That means the domain is all real numbers, and that's represented with this awesome R. So this R here tells us that the domain is all real numbers. We'll put that in parentheses here. All real numbers. Alright, the range now. The range, if we recall, is the output, right? It is what's being outputted, those values. Now, when we notice on our graph, it's just this wave here, and it's bouncing between 1 and -1. That means our range is going to be y values from -1 to 1, and that is all. We will see later on how we can change the range through transformations, okay, by shifting graphs up and down and whatnot. But for now, this is what we're gonna focus in on. So sine has a domain of all real numbers and range from -1 to 1, and the period is 2 pi. Alright, so now we will look at cosine, and it's going to be rather similar here. So we could make a table of values if we wanted to, but for the sake of time, we won't. So if we plug 0 into cosine, then we know that cosine of 0 is 1. That's just, again, unit circle. So there's our first point. And if we go out to pi over 2, we recall also that cosine of pi over 2 is 0. So we go down. That actually looks like a decent curve. Alright, we're getting better at this. And then when we plug pi in, we actually go down to -1. So that's going to be down here about. Here we go. Oop, nope. We jinxed it. Rip curve. Maybe we can make it better. Alright, awesome sound effects. Thank you to me for providing that. Alright, 3 pi over 2. We're back up to 0. And then that leaves 2 pi, right? If we go to 2 pi, we are back at 0. And we can note that this curve will continue on and on for infinity. And it looks kind of suspicious, really, like the sine curve, right? I mean, we were to go out another pi over 2, so this would be 5 pi over 2. Well, that's the same thing as pi over 2. And we're back down here, and look, it looks like a sine curve that's just been shifted over, left or right. And, in fact, we will prove that is later. Alright. For now, we're just going to note that, that looks suspicious. So, you can see that the domain here is also all real numbers. The range is still going to bounce between -1 and 1. And we're going to have a period of 2 pi. Alright, let's go ahead and get this on Desmos here. So we're going to turn sine off and turn cosine on. Here we go. Ooh, see, nice and wavy, clear, crisp lines here. In fact, remember, let's turn projector mode on. Now we got bold, crisp curves. Alright, and we can see here is sine. So the graphs here seem to give credence to my claim that the sine and cosine curves are just horizontal shifts of each other. But again, we haven't proved that yet, but it's definitely looking very plausible based off these graphs. Well, we're going to conclude this video, and we'll just break this up into a series of 3 parts. So the next video will cover tangent, cotangent, and the last part will look at secant and cosecant. So thank you for watching this video. If you've been enjoying our content, please subscribe and consider supporting us on Patreon. And by doing so, one of my goals is to purchase some works on the history of mathematics so I can give further background information into the historical motivations for why mathematicians considered such things such as trig with concerning sines and cosines within circles and those ratios of those angles. So if you're interested like I am, I do have a Patreon goal set up, and the book's out of my budget because as a high school teacher, there's just some things you can't buy all the time. One of those is books. Expensive books, that is. Alright. Well, thank you for joining our math party, and I will see you next time.